Hi guys, and here is the video for the properties of parallelograms worksheet. Numbers 1 and 2 we'll talk about in class. You just need to make sure that you stated a reason why you picked the vertex to go where you did. Alright, so let's talk about number 3. The first couple are fairly simple. So they're saying that AB, so here's AB, is equal to 7, and BD is equal to what? So what is this right here? Okay, remember, if you have 3 parallel lines or 4 parallel lines and they're cut with a transversal like this, okay, and they're telling you that each segment that it creates is congruent, then that means that if you have another transversal right here, when it cuts across those segments, those distances between the parallel lines are going to be congruent as well. So basically, what that's telling us is that AB is 7. That also means that BC is 7 and CD is 7. So BD would be this distance right here, which is 7 plus 7. So that means that BD is equal to 14. Okay? Alright, second one, or sorry, number 4. So this is saying that AD, this distance right here, is equal to 24. Okay, we know that all of these are congruent. Okay? So basically you just kind of have to think to yourself, if the whole thing is 24, it's cut into 3 parts, what has to be the amount of each one? So you would do 24 divided by 3 gives you 8. That means that each one of these is 8. So BC therefore would be 8. Alright, on to number 5. Okay, so this one says that CD is equal to 5x. So this is CD right here. This is 5x. And BC is equal to 2x plus 5. Okay, remember we know that those two are congruent. So we can say that 2x plus 5 is equal to 5x. Then we solve for x, so minus 2x minus 2x. 5, I did this again, should be 15. Okay, so 15 equals 3x, so that means that x is equal to 5. Okay, pretty simple. Alright, number 6, it says that AC is equal to 44 minus 2x, so that means that this whole space right here is equal to 44 minus 2x. Okay, and BC, which is this right here, is equal to 3x minus 22. Okay, if the whole red portion AC is equal to 44 minus 2x, that means that AB, this part right here, is equal to half of that. So that means we can take 44 minus 2x and divide it by 2. So that would be 22 minus x, right, that's this distance right here, is also equal to BC, so that's equal to 3x minus 22. Okay, so we're going to add x here and add x there. We get 22 equals 4x minus 22. Then add 22, and that gives us, I'm going to come over here, 44 equals 4x, so that means x is equal to 11. So x is equal to 11. Alright, number 7. Okay, this one is telling us that AB, right here, is equal to 24. It says that BC is equal to 2x x minus y, and CD right here is equal to x plus y. Okay, so basically that's just saying that all 3 of those segments are equal to each other. They've all got different values. Now we have an x and a y, so you know that means that we're going to have to set up a system. So let's go ahead and start off with, if this is 24 right here, we can set that equal to 2x minus y. So 24 is equal to 2x minus y. Okay, And then we can also write 2x minus y is equal to x plus y. Okay, the first one I went ahead and set these two equal to each other, and on the second equation I set these two equal to each other. Okay, so we need to change this one around so that it looks like the one on the left. So let's go ahead and change things around. So this gives us, if I take away x here, that gives me x, and then if I subtract y here, then subtract y here, I have minus 2y. These are all gone, so I have 0. Okay, so that becomes, I'm going to rearrange this one to be 2x minus y equals 24, and then we've got x minus 2y equals 0. Okay, these are the two equations we're going to work with. Okay, so we know it's a system. That means we need to be able to put them together and get rid of one of those variables. So to me, the easiest thing is going to do to multiply this one through right here, multiply it by -2. I'm not going to do. Okay, so that gives me 2x minus y equals 24. And when I multiply this through by -2, I get -2x plus 4y equals 0. Then when those cancel to be 0, I've got 3y equals 24. So that means y is equal to 8. Okay, so y is equal to 8. Then we're going to plug it back in to get our value for x. Okay, so we can do 2x minus y equals 24. And then we can go ahead and plug in, so 2x minus 8 equals 24. 2x equals 32. So x is equal to 16. Okay, and you can plug those numbers in to verify that it does make each line segment equal to 24. All right, number 8. All right, we want to solve for the value of y. There's a couple ways to do this. First of all, you know that if it's a parallelogram, that this line right here and this line, okay, they're parallel. So that means that your transversal, which is this line right here, means that this angle and this angle are congruent. Okay, so let's start there. So what I would do is I would say that you know if this is 98, this one is also 98. So now how do we solve for this one? We do, for this one, you do 98 plus 31, it's 129. We know that the triangle has to be 180, so 180 minus 129 is 51. So that means that this angle right here is 51. Okay? So now we know, since we have parallel lines, that this side, that this angle and this angle are congruent. So now we can say 6x plus 3 equals 51. So we subtract 3 from both sides. We get 6x equals 51 minus 3 is 48. So that means that x is equal to 8. Okay, I'm going to write this here. X, 8 equals x. Okay, so let's go ahead and erase this. Alright, so we know that this one is 51. Okay, so that means that we want to know, we have this y here, so we want to find out what this one is. So we know that if this one's 98, right, these ones right here, they're supplementary to each other. So if that's 98, 180 minus 98 oops, I can't subtract tonight. Okay, is 82. So that means that this angle right here is 82, okay? So if this is 52 and this is 82, right, we have 52 and 82 there. So 52 plus 82, that's 134. This angle measure over here has to be 180 minus 134, which is 46. So that means that this right here is 46 degrees. So I'm going to take that and I'm going to set it equal to 46. So 4y plus 2 equals 46. So take away 2 from both sides. 4y equals 44. Y is equal to 11. So 11 equals y. All right. Number 9. Okay. So what do we know? We know that this angle and this angle are congruent because it's a parallelogram and opposite angles are congruent. So we have 8x minus 10 equals 62. So that's 8x equals 72. So x is equal to 9. Right? X is equal to 9. That one's fairly simple. All right. We also know that these two angles right here are supplementary. Okay? So that means if we know that this, and actually let's even state that differently, make it easier, that these two angles right here are supplementary. So that means we have 9y plus 1 plus 62 equals 180. So 9y plus 63 equals 180. If I subtract 63 from both sides, I get 117, and then 117 divided by 9, y is equal to 13. So y is equal to 13. All right. Number 10. Okay. So on this one, we're trying to solve for x and y also. So let's see some things that we know. We're talking about the diagonals and the side lengths. If this is a parallelogram, this side is congruent to this side. So we would do 2x plus 5y equals 30. Okay. We also know that if this is a diagonal, they've been bisected, so this 2x plus 2y is equal to 18. So we have 2x plus 2y equals 18. All right, so we have two variables, x and y. So that means it's a system we want to solve. So to do that, we're going to multiply this side through by -1. Okay, so this one stays the same. We have 2x, 2x plus 5y equals 30. This is now negative 2x minus 2y equals negative 18. Those cancel. We have 3y equals 12. So y is equal to 4. So we'll do that. Y equal to 4. All right. So now what we do is we take one of those equations and we plug y back into it. Okay. So if 2x plus 2y equals 18, we plug in 4 for y. That gives us 2x plus 8 equals 18. Subtract 8. 2x equals 10. So x is equal to 5. So x is 5. All right, last one. This is a factoring one. Okay. All right, so we know that this side is congruent to that side, and that side is congruent to that side. Okay. So we set it up. We start off with y squared is equal to 21 minus 4y. Remember, when we have quadratics, we want to set it equal to 0. So we're going to move everything over to one side. So in order to do that, I'm going to add 4y to both sides, and I'm going to take away 21. Okay, so I'm going to add 4y here. I'm going to take away 21. And basically all I'm doing is rearranging. So now I have y squared plus 4y minus 21 equals 0. Okay, so now I need to ask myself, what multiplied together gives me 21 and added together gives me 4. So that's y squared, and we know that it's got to be a 7y minus 3y minus 21 equals 0. Factor out my y plus 7, and my negative 3, y plus 7. Okay, so that becomes y minus 3 times y plus 7. If I solve for y in each of those, I get y is equal to 3 and negative 7. Okay, let's go ahead and do the x. Alright, so the x is x squared equals 2x plus 15. Alright, so if we move the 2x over, that becomes x squared minus 2x, gets rid of that, minus 15, gets rid of that, equals 0. Alright, what two numbers multiplied together will give you 15, but added or subtracted gives you negative 2. So factors of 15 are 5 and 3. So this is x squared minus 5x plus 3x minus 15 equals 0. Factor out my x minus 5 and 3, x minus 5. So that becomes x plus 3, x minus 5. And when I solve for x, I get x is equal to negative 3 and 5. And for right now, I'm just worried about you guys solving for those distances, and we could plug them in to see which one works or doesn't work. All right, well, I will see you all in class tomorrow.